In this lecture, we will talk about the SQL Recursive Query. With the SQL Recursive Query, by definition, we recursively or repeatedly join tables together until we get the data we want. The SQL Recursive Query could be very useful in scenarios such as create an organizational report listing the level each employee is at. Let's look at some code. For this lecture, we are going to use the Northwind database. We are going to use the employees table of the Northwind database. First of all, we want to update the table content to make the hierarchy deeper for demo purposes. We are going to use the update statements. Let's run them. Now, let's see what we have in the employees table. In the employees table, we have the employee ID for each employee, last name, first name, title, and the reports to column. The reports to column has an employee's manager. We have 9 employees in this table. As we can see, everyone except Fuller has a manager. Fuller is the big boss. Fuller does not have a manager. So the reports to column has a no value. Now let's look at the recursive query. When we write a recursive query, we need to retrieve the first row of the dataset returned by the recursive query first. Usually, the first row of the dataset is called the anchor. In our example, the first row is the big boss. This query will retrieve the first row of the returned dataset, or this query will retrieve the big boss. Pay attention to this column. We give this column an alias label. This becomes the column name of the returned dataset. The big boss is on top of the hierarchy. We start with 0. So 0 is the top level. We put a pair of brackets surrounding level because level is a SQL keyword. We do this as a best practice. Also, pay attention to the manager name column. We specify a data type, Unicode varchar 20. Then we use the convert function to convert this column to a no value because the big boss does not have a manager, so the manager name is no. How do we know we need to use Unicode varchar 20? Let's see. If we go to the Northwind database, we go to Tables. We look at the employees table. Look at the columns. We can see that the last name column has the data type Unicode varchar 20. This is how we know that we need to use Unicode varchar 20 here for the manager name column. Remember, the manager name column has the manager's last name. Also, in this query, we specify reports to is no because the big boss does not have a manager. So this query again will build the anchor or will retrieve the big boss or the first row of the returned data set. We need to use union or to combine the first row with remaining rows to build the complete data set. We have to use union or. We cannot just use union. If we just use union, we will get an error. This query will retrieve everyone else that has a manager. Pay attention to this column label. When we go through each recursion, we increment the label by 1. Also, we use this correlated subquery to retrieve a manager's last name. The recursion takes place here. We join employees with direct reports recursively or repeatedly until we get all of the data we want. We join on the common columns. The common column is employee ID. Keep in mind, managers are also employees. So that's the reason why the common column is employee ID, because we have employee IDs in the reports to column. Once the common table expression is defined, we can select columns from the virtual table created by the common table expression. If we just want to retrieve employees at a specific level, we could use the where clause to specify the level we want. Now, let's run the recursive query. We have a nice looking organizational chart report with the level each employee is at listed, and we can see on the report the Big Boss Fuller is on top at level 0. Again, the Big Boss does not have a manager. The recursive query may appear to be complicated and confusing initially, but it is indeed very interesting and powerful. This concludes the lecture on SQL Server Recursive Query.